Welcome to a tutorial of ProfLearn YouTube channel. In this particular video, we're going to have a discussion of the topics that you need to prepare for additional math. If you are doing the receipt of November 2025, or you are doing May-June exams of 2026, or you are having Web Match paper of 2026, this paper is for you so that you can be able to see which are the topics that you must give gravity in that particular papers you are preparing. And if you're new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload another tutorial, you'll be notified. In ProfLearn YouTube channel, we do maths and physics, additional math, and pure math. So consider subscribing so that anytime I'm going to upload more tutorials, you'll be in a position to be notified when there's a new video. Now, one of the area that you need to prepare as far as this particular paper is concerned is that you need to understand the concept of trigonometric proofs. Now, in this case, as you can see here, we have a question whereby we are supposed to prove and show that we need to prove and show that sine x over tan x minus 1 minus cos x over tan x plus 1 is equals to cos x divided by sine squared x minus cos squared x. So this is exactly what we need to prove here, and we're going to follow easy steps so that we can be able to check how do you really approach this kind of question and what are you expected to do in order to earn the marks for this particular question. So in order to prove this, the way I usually advise my student is that you are going to choose which part are you going to use. You're going to choose the part you are going to use in order to show the proof. Number one, you can say using the left hand side to show the right hand side. We are going to use the left hand side to show the right hand side. How do you do that? If you look at this part that we're having here, this is sine x. We can be able to write tan as sine x over cos x minus 1, then minus cos x over sine x over cos x plus 1, because this is the plus. In order to get rid of this particular part, there are a few things we can decide to do here. Yeah, there are a few things that we can be able to do here. We can express this part as single fraction, of course. So this is going to be sine x over sine x minus cos x over cos x minus cos x, and this part that we are having here can also be expressed as what? Can be expressed as sine x plus cos x over cos x, right? So meaning that if we decide to multiply numerator and denominator, if we decide to multiply by numerator and denominator by cos x by cos x, here by cos x and cos x, it goes without saying that this part and this part will cancel out. and also this part and this part will cancel out. So we are going to remain with sine x cos x over sine x minus cos x minus cos x squared, because cos times cos is going to give us cos x squared over sine x plus cos x. The next thing we are going to do is to express as a single fraction here, but to do that we are going to take the whole of this multiply on the other side and the whole of this multiply to this other side. Then we expressed as sine x minus cos x into sine x plus cos x. This multiply to this one is going to be sine x cos x into bracket the whole of this, which is sine x plus cos x. This multiply there, we shall have minus cos squared x into sine x minus cos x. So we need to be very careful the way we are going to expand this, because if you multiply this and this, we are going to get sine squared x, this and this sine squared x cos x. This one multiplied to this, we are going to get plus sine x cos squared x. This and this is going to be minus sine x cos squared x, because if you multiply cos squared x times sine x, what does it give you? It's going to give you sine x cos squared x. Minus minus is going to be positive, so that's going to translate to plus cos cubed x. We have cos cubed x at that point. And also if we try to expand this, we are going to have sine squared x. This time this will be plus sine x times cos x will be cos x sine x. Cos x times sine x will be minus sine x cos x. Cos times cos will be minus cos squared x. Now you can realize that at this point of time, this part and this part will cancel out, and also we shall have sine x cos squared x. This term and this term will cancel out. Then we're going to remain with a part that is sine squared x cos x, right, plus cos cubed x. So if I factor out, and this is sine squared x minus cos squared x. So if I factor out in this part cos, if I factor cos out, we are going to remain with what? We shall have cos x into sine squared x plus cos squared x over sine squared x minus cos squared x. So the whole of this that we have here is equals to 1. Yeah, so it will mean that in this equation that we are having here, we are going to remain with cos x over sine squared x minus cos squared x. So this is the final expression where we are getting after working all this. And indeed you can see, let me just zoom this a little bit. Indeed you can see that this equation that we have gotten down here, this equation that we have gotten here is basically what we were supposed to show at this given point. So that is exactly what you are supposed to do in order for you to work out those questions. So as you are preparing for your additional math paper, you have to ensure that you understand how to work questions which requires you to do some proofs like this, trigonometric proofs, in order for you to earn your mark. And if you would like to download this paper, you can be able to check it in the description. There's a link that is going to take you straight so that you can be able to download that. Now, other than trigonometric proofs, you need to understand the concepts to do with determining periods of trigonometric functions. Now, for instance, if you are having y is equals to 5 tan x over 4, and you are supposed to write down the period of this, you need to remember period is equals to, and they are saying in radians, in radians, period is pi over b. And what is this b we are talking about here? Our b is the general, this is the general equation. If you're having the equation y is equals to a tan of bx, yeah, this is the general equation of a tan, then the period is going to be pi over b, the coefficient of x that you're having there. But in this case, the coefficient of x is 1 over 4. So this is going to be pi over 1 over 4, and that is going to be 4 pi. Our period is going to be 4 pi in that case. We are given a question, and then we are supposed also to sketch the graph of y is equals to 5 tan x over 4 plus 1. So something that we need to have in mind at this given point is that anytime you have a tan, it has asymptotes. It has asymptotes. So if you want to find the points where the asymptotes are, so let's give us a general equation y is equals to a tan bx plus c, and then we can say now plus d. That's the general equation of a trigonometric function. If you are having such an equation, then you need to remember that this part here will give you the period. It will enable you to get the period for this part. Then the asymptote is always areas where the function is undefined. In that case, we're going to say the asymptote is going to be bx plus c, bx plus c is equals to pi over 2 plus n pi, whereby n is going to be equals to 0 plus or minus 1 plus or minus 2 plus or minus what? 3. These are just integers so that you can be able to get it. So in order for us to use this equation in our case, our C for the equation, our equation is what? The equation is y is equals to 5 tan x over 4 plus 1. So you can see in our case here, our C is 0 and our B is 1 over 4. So meaning this is going to be 1 over 4 x plus C. Our C 0 is equals to 2 pi over 2 plus n pi. Plus n pi. So the first asymptote is going to be at this point where we are going to say when n is 0, so that's going to be x is equals to pi over 2 times 4. I've just multiplied this 4 on the other side, and that is going to be at a point where it's going to be 2 pi. So the first asymptote that we are going to have in this case of our question is going to be 2 pi. At 2 pi. The second asymptote is going to be on the left hand side when it's going to be 1 over 4x is equals to negative 1. Negative 1. So this pi over 2 minus pi. So if we multiply by 4 all through, we are going to have x is equals to 2 pi minus 4 pi, and that's going to be minus 2 pi. So that is the second point where we are going to have our asymptote for this particular question. So let's check. Our graph was given here. Negative 2 pi, we have 2 pi and positive 2 pi. So let me just draw that nicely. Our graph will be like that. Let me just move this a little bit. Just put our graph here. To put our graph here. Then we have, this is the y-axis. And then we have our 0 here. We have negative 2 pi. This is 2 pi. And then I have 4 pi at this point. So that's how the graph looks like. And our graph is supposed to be drawn for the range x greater than 4 pi and negative 2 pi. Yeah, so that is how our graph will look like. So you realize that the first asymptote we shall have is at this particular point here, which we have indicated. We got it here. Here, this asymptote. Now it will come like that. And the second asymptote will be at this particular point. Yeah, so that is the first asymptote. So you realize that your graph is going to behave like that. The graph will come like that, and then it will approach the asymptote, and then it will disappear there. And this one, the graph will move that way. Yeah, so that's basically how this particular graph will look like. Yeah, so basically that's how this graph will be looking like. So the next area or the next questions of interest is questions to do with series. And when we are saying question to do with series, what we mean is question of AP and geometric progression. we have arithmetic progression, geometric progression, and binomial expansion. So we are going to first look at arithmetic and geometric progressions so that you know which area that you need to focus. Now, anytime you are going to do geometric progression and arithmetic progression, what you need to remember is that for AP, there are quite very important formulas that you must have or you must know. Number one is the nth term. Nth term of an arithmetic progression or series is A plus n minus 1 into D, where D is the common difference, A is the first term, and n is the number of that particular term that you are trying to look for. The second formula that is important is the sum of n terms is given by n over 2 into brackets 2a plus n minus 1 into D. This is the second formula that you must know. The third formula that you should know here is S of number of terms. In this case should be n over 2, sum of n terms. When you are given the first term and the last term, you should use this formula. So you should understand how to use this formula before you sit for your exam. The second part is geometric series, that is GP. What are the formulas that you need in that case? You need nth term for a geometric progression is going to be A r n minus 1, where A is the first term, R is the common ratio, and n number of terms. So sum of terms is going to be A into Rn minus 1 over R minus 1. This is when R is greater than 1. You will use this formula when R is greater than 1. But if R is less than 1, you are going to have Sn is equals to A into 1 minus R raised to power n over 1 minus R, and this is when R is less than 1. Lastly, for geometric series, if R is less than 1, then we can say that this series is convergent. And if the series is convergent, it means there exists sum to infinity. You can be able to find sum to infinity. And to find sum to infinity, you are going to say its first term over 1 minus the common ratio. I believe we are together up to this point. Now, anytime you are given a question, now for instance here, we are told that the geometric progression as the first term A, common ratio R, the sum of the second and third term of the progression is 168. So which means that we can be able to form an equation for this question number 3. Let's go ahead and try to form that equation. Now, to form that equation, we are going to say the first equation is sum of the first term, the second term, and the third term. So meaning second term of an arithmetic geometric progression is going to be A R. That is the second term. Then plus the third term, which is A R squared, should be equals to 168. That's the first equation we should be having at this point. And this one we are going to call it equation 1. Once we have gotten that, we are going to proceed to the next statement. The sum of the second and that, we have gotten that. The sum of the fourth and fifth. So what is the equation of the fourth? Expression for the fourth term. Fourth term is A R power 3. A R power 3 plus A R power 4 is equals to 94.5. And this becomes equation number 2. Now, to solve this, we are going to say dividing equation 2 by equation 1. What are we going to have? We are going to have a r cubed plus a r power 4 is equals to 94.5 over a r plus a r squared over 168. Now we can be able to factor out what is common here. We can be able to factor out on the numerator. We can factor out a r power 3. We shall remain with 1 plus r over, we can factor out a r here. We shall have 1 plus r is equals to, if you are having 168 in this case here, I'm just getting a calculator so that we can be able to continue. So if we take 94.5, and of course don't forget that this part and this part will cancel out, a and a will cancel out, r and r is going to cancel out, and then we're going to remain with r squared is equals to what? 94.5 divided by 168, that's going to be 9 over 16, and this is 9 over 16. So meaning that if you find the square root, we are going to have our r is equals to 3 over 4 plus or minus. Why are we saying plus or minus? Because this is a square root, and when you find the square root of a number, is plus or minus, but therefore we're going to say r is equals to 3 over 4 or negative 3 over 4. But they are saying here where r is greater than 0, so we are going to discredit this. The answer cannot be this, so our correct answer is 3 over 4. So if we can go back to the question so that we don't lose track, we are being asked the sixth term, so meaning that we need to know what the first term is. We can now say, using equation 1, if we use equation 1, what are we going to have? If we are using equation 1, what are we going to have? If we are using equation 1, our equation 1 is here. So we are going to say AR plus AR squared is equals to 168, but our R is 3 over 4, so it is going to be 3 over 4A plus A into 3 over 4 squared is equals to 168. So if we have that, it will mean that 3 over 4A plus 9 over 16A is equals to 168. So if you add 3 over 4 plus 9 over 16, we are going to have 21 over 16. So meaning that 21 over 16A is equals to 168. 168. So our A is going to be 168 divided by 21 over 16. So 168 divided by the answer that we have, and the answer A becomes 128. So we have our A being equivalent to 128, and our R is 3 over 4. So once we have this, we can now be able to find the sixth term, whereby we know that the sixth sum is U6, we can call it U6, is going to be, the first term is 128, yeah, because the formula for nth term is A, first term, R, n minus 1. Now in this case n is 6, so meaning that this is going to be 3 over 4, 6 minus 1. This is going to be 128 into 3 over 4 raised to power 5. Yeah, so if you just work it out, 128 times into bracket 3 over 4 into raised to power 5. If you work it out, you are going to get your answers 243 over 8. So this now becomes the final answer for that case. The next question that is I foresaw that will be asked here is the question to do with sum to infinity. Sum to infinity. How do you do that? In that case, it's very simple. That is part B. This was part A. Now moving to part B, sum to infinity. Find the sum to infinity of the progression. So sum to infinity is going to be given by the formula A over 1 minus R. In this case, is our A is 128 divided by 1 minus 3 over 4. Yeah, 3 over 4. And if you work it out, you are going to get 128 divided by 1 over 4. So if you work it out, so it will be 128 over 1 over 4, which is going to translate to 512. 512 as the answer for that. And if you are new to Profland YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. All right, so another type of questions that you may be asked to work out as far as this question is concerned is whereby you are given a question like this under arithmetic and geometric series. So I decided to give you a classical kind of questions that you really expect. If you cannot be given a question like the previous one that I gave out, you can be asked a question like this. Arithmetic progression. In an arithmetic progression, the first term, the sum of the first 30 terms is negative 1065. So which means that we can be able to form an equation there. And we're going to say, in this case, that the sum of the first 30 terms, so that is going to be 30 over 2, 2a plus n minus 1. N minus 1 now becomes 30 minus 1 becomes 29 of d should be equals to negative 1065. So if you have divide here, you're going to have 15. So meaning that we are going to have 2a plus 29d is going to be equals to what? If you take 10 negative 1065 divided by 15, you are going to get negative 71. So if you have negative 71 here, we are okay. We can say this is our equation number 1. The sum of the next 20 terms is negative 2210. The sum of the next 20 terms. So which means the way we're going to approach this question, we're going to say sum of the first 50 terms minus the sum of the first 30 terms should give us the sum of the next 20 terms, and that is going to be negative 2210. But in this case here, we know that the sum of the first 30 terms is this particular part that we are having here, negative 1065. So it goes without saying that we can be able to write an expression for the sum of the first 50 terms, and that is going to be 50 over 2 into 2a plus n minus 50 minus 1, that will be 49, into d. Yeah, then minus, instead of writing the expression also like this one for sum of the first 30 terms, we can substitute there and say minus negative 1065, because we were already told that the sum of the first 30 terms is negative 1065. So we can be able to use it at this point here. We can comfortably use it there instead of putting an expression. But also, if you put an expression, the answer still will be correct. That will be able to, it will be able to work. Yeah, it can work. So we are saying minus negative because this value was a negative, and that should be equals to negative 2210. So at this particular point, this sign that we have here will be positive, and then we'll be forced to take this guy on the other side of the equal sign. So once you have taken that on the other side of the equal sign, it will mean that this is going to be 25 into brackets 2a plus 49d is equals to negative 2210 minus 1065. All right, so if you take negative 2210 minus 1065, that's going to be negative 3275. So this becomes 2a plus 49d is equal to negative 3275. So I will divide this guy that I'm having here, 25, because after getting this sum here, I can now comfortably divide by 25 so that I can be able to get what this simplifies to and avoid having very big numbers at that point. So this is going to be 2a plus 49d is going to be equals to what? If I divide by 25, that's going to reduce to negative 131. And now this becomes our equation number 2. Then now we can be able to solve the simultaneous equations that we are having here. We can say solving equation 1 and equation 2. Let's see, where is our equation 1? Our equation 1 is well seated here. So we are going to say this is 2a plus 29d is equals to negative 71. And then we have 2a plus 49d is equals to negative 131. So if we subtract the two equations, you will see that this guy and this guy will commit suicide. Then we are going to have negative what? Negative 20d is equals to, if you are having, don't take chances, if you are having negative 71 minus negative 131, you are going to get 60. If you have 60 there, then you can say you can divide by negative 20, divide by negative 20. Then we can now see that this guy and this guy will cancel out, and our d is going to reduce to negative 3. Now this becomes our common difference. Now once you have the common difference, what next? Find the first term and common difference. So once you have gotten the common difference, you can say now using equation 1. You can use n, you can either use 2 or 1. So using equation 1, what are we going to have? That is going to be 2a plus 29d, but our d is negative 3, is equals to negative 71. So that's going to be 2a is equals to negative 71 plus, what is 29? 29 times 3, that is going to be 87. So meaning that 71 is going to be 16. So 2a is going to be 16. Divide by 2, divide by 2. Our a is going to translate to 8. Our a is 8, and our common difference for that case is going to translate to what? Our common difference has translated to -3. So up to that point, guys, why can't you subscribe? If you are new to Proflan YouTube channel, why? Just subscribe to support Proflan, and once I'll be doing more tutorials, you'll be notified. You'll be notified. Now let's dive in for part B of this. Before we go to series, let's dive in for this particular part that we are having here. Just want to move to part B. Yeah, so I'll be uploading this in our Patreon page so that you can be able to download this paper so that you have it with you. Yeah, so just check the description. We have our Patreon page where you can be able to access all these PDF, guys. Yeah, our Patreon page, you'll get there exclusive videos. Yeah, you'll get there the PDF, the notes. Yeah, so check it out, guys. Check it out before we move to the next part. All right, so a geometric progression is such that the first term is 4 and the sum of the first 3 terms is 7. So we are told that the first term a is 4 and the sum of the first 3 terms is 7. So in order to work out this, what you needed to remember is that sum of n terms of a geometric progression is a into Rn minus what? Minus 1 over R minus 1 is equals to, yeah, it's just the sum, sorry, yeah, it's the sum. Then in our case here, we are going to say this is 4 into R raised to power 3 minus 1, isn't it? The first 3 terms, so it will be 3 minus 1, part 3, sum of the first 3 terms. So why am I confusing this? The sum of the first 3 terms. Yeah, so yeah, so this is going to be R minus 1 is equals to, the sum is 7. Yeah, I don't know why I'm confusing it, but you need to be very careful. So this is going to be 4R cubed minus 4 is equals to 7R minus 7. So if we take this guy on the other side, we shall have 4R cubed minus 7R, and that's going to be plus 3 is equals to 0. Now having this, and if you solve this, you are going to get R being equals to 1, R equals to R equals to 1 over 4, or I think I'm